Yeah, Chris Porter. I'm an infrastructure architect at a bank in London. And I recently had to recertify in my AWS Cloud Solutions Architect. So that's how long I've been doing it. It kind of cropped up. So a couple of years, 2015, I started playing with this. But yeah, I run a big VMware estate, and we run increasingly more and more stuff in AWS. So kind of cross both things. So hopefully somewhat qualified to talk about it. But you can't run now. We're closing the doors. So.
So we've actually presented this a few times across the country at different VMUGs, but we thought today, as it was a special VMUG, we've revamped it with all new memes for those of you who may already have attended the session. But before we kind of get into the content, we kind of wanted to know about who was here in the room and what it was that you were looking to get out of the session. So first of all, if you can put your hands up, have you played with AWS before, like hands-on, even if you've just signed up for an account and messed about with it? So a bit over half the room, 2/3 of the room, okay. Do you have any AWS experience actually on the job at work? Hands up again. So very, very small number, okay. Are you using it in production today at work, of the 2 people who put their hands up? There we go, okay, we've got 3. And then finally, of everybody else who's in the room, are you planning to do any AWS certs, let's say in the next 6, 12 months, anything like that? So yeah, more than half again. Okay, right, really interesting. So I guess the thing I alluded to earlier on, we're not VMware haters. You know, we've been attending VMUGs for many, many years. I think I was wearing my 2013 VMUG t-shirt last night when I came in. And we're massive fans of the ecosystem. But at the same time, we can't bury our heads in the sand as to all of this AWS stuff going on in and around the ecosystem. Why else are we talking about it today? Because paradigms. So I have like an aversion to that word. So I try to include it in every presentation that I do just because it helps with like aversion therapy. It's such an absolutely insanely horrific word. But it is changing. You know, we're changing the way that we actually do business, as well as changing the way that we actually work IT into that business paradigm. So for example, we're looking to deliver things more on demand rather than these big static environments that we always had in the past. Rise of the generalist. Now this is something, you know, you look back 5 years ago, you had your cloud specialist, well, maybe a few of them. You had your storage specialist, you had your VMware specialist. But actually moving forward, what I see in the job market and what I see in what people are talking about online is that companies are looking for people who have a broad set of skills, but maybe kind of like the T-bar. So you're going to have a broad set of skills across a large number of technologies and maybe specialize in 1 or 2 of them. And certainly that full-stack engineer, which has been kind of bandied around a lot as well, is definitely where things are going. So again, it's another driver towards why would we want to actually increase our skills and start looking at additional technologies that start coming down the line. And finally, yeah, we can't ignore the 800-pound gorilla. AWS, all you have to do is look on the register front page on a pretty much daily basis, and there's going to be an AWS story about how they're absolutely smashing their numbers, how they're growing, how they're increasing the number of products and services that they're providing day in, day out, and just wiping out a large segment of the market. And finally, because of VMware on AWS, so VMware Cloud on AWS, the thing that was announced towards the, how long ago was it?
Last year.
It was last year now. This is how long we've been doing this presentation. You can tell by the polished effect of this. But when VMware Cloud on AWS was announced, that gave us an opportunity to walk into a VMUG and actually start having conversations without getting frowned at too much, which was quite nice. Now, what we've designed with this kind of session is it kind of goes through from on an assumption that people in the room have very little knowledge about AWS, so we go through some of the basics. Then we start to talk about kind of our experiences with AWS. And then there's some hints and tips at the end around how you might get certified if you want to go down that route. But we have an absolute ton of information, so we're going to kind of fly through it as fast as we can. So if we speak fast, that's why. The first thing is, when you log in for the very first time, so a few people put their hands up and said, yeah, I've logged into the AWS console, but I've never actually done anything with it in production, or I've never done it at work. The first thing you see is this huge big swathe of products, and you think, oh God, right, if I'm going to get certified, do I have to know every single thing that's on that slide? That's a slightly daunting task, but the fact is, I know quite a lot of guys who work, and girls who work at AWS as solution architects. They don't even have to know all of this stuff. So the idea with AWS is, make sure that you have a good grounding on the core things that you need to know, the basics, and then maybe start to specialize in an area that interests you. So that's exactly how they do it at AWS. They'll have like a mobility specialist. So they know the basics of all the normal products, and then they know really in depth about the mobility products, that kind of a thing. So what I would recommend, if you're starting to get into this, is approach it in exactly the same way that you approached learning about VMware and learning about infrastructure. So you need to understand networking. You need to understand compute, storage, and data that's sitting off the back of it. And finally, and most importantly, I guess, security.
So to kind of put the foundation in for the understanding of AWS, we start with looking at networking and regions and availability zones. This is actually the regions and availability zones as it was in January of this year, and when we started, and then this is where they are now. So there's things like in the US East, they put 6 availability zones in, there was 5, they've announced Hong Kong, Paris, Sweden. This is in 9 months. This is the pace that this is growing at. And a region is, I don't know if we talk about this on the next slide. This is how polished this is. But so a region is a group of availability zones, and you're not really meant to talk about this, but as data centers. But that's effectively, if you think about it in a VMware mindset, an availability zone is a data center. And if you're designing, which we'll talk about a bit later on, things in AWS, you're looking at using those data centers to spread your workloads between if you're doing a more sort of traditional DR and using the infrastructure services. We jump onto the next slide. So within each region, you have a VPC, and that's kind of like a metro network. So that's what links together those availability zones, and that's where all of your resources in AWS, that's where they live, within that virtual private cloud. And you connect into that VPC your external connectivity, whether that's a VPN or a direct connect. And a direct connect is a leased line basically into your own existing networks, and you can get that in a 1 or a 10 gig. So this is something we do at my work, where we actually make our AWS infrastructure just look like another data center or a set of data centers as part of our internal private network. Within a VPC, you get subnets, you get routing tables, you get NATs, you get the kind of normal things that you would expect from a network. And then you get on top of that, you get security groups. And security groups are kind of micro-segmentation. They're not as powerful as NSX, but they allow you to logically group things into, say, these are my web servers, or these are this application servers. And it doesn't matter which subnet they sit in, or which availability zone, but you can scale by adding new servers into those, or EC2 instances into those security groups, and they instantly inherit those rules. So you're not having to manage IP addresses for every new thing as you add them. And so that's really quite powerful, and a new paradigm in security. But whilst you kind of get those normal sort of things, there's quite a few things you need to consider, especially coming from a VMware background, you might expect is in the environment that actually isn't there. So like a lot of clouds, they don't allow broadcast or multicast. So things like firewalls you're putting in that might talk on multicast, that's all kind of blocked. You're not going to get network access. You're not going to be able to do port spanning, port mirroring, those kind of things. So IPS and things like that, you have to think differently. And a lot of those providers and security vendors have worked with AWS to come up with new ways of monitoring traffic and plugging into these environments. The multicast and those kind of broadcasts, those kind of things, you're not going to see. Pixie isn't going to work. So you can't, if you're trying to spin up machines using Pixie, or you want to put DHCP servers in, DHCP servers aren't going to work. You get an AWS DHCP server, you can't put your own DHCP server in. So you kind of need to think about these things. There are some gotchas in the networking. And a new thing that was released recently is direct connect gateways. If you are putting those direct connects in, you can now connect into one region and make that direct connect available to connect into any of AWS's regions. So you can't actually natively within AWS do connectivity between regions. You have to put VPNs in, or you have to put a VPN back to your site and then route between them. It's been something they've been looking, or people have been asking for a long time. Something Google and Microsoft do in their clouds to allow you to cross-connect between regions. It may come at reInvent in a couple of weeks' time.
And we forgot to mention that in the intro, didn't we? reInvent is in a week, so basically everything we're saying now is probably going to be completely changed in about a week. So
and it might change within the next 5 minutes. The amount of stuff that AWS are releasing and trying to get out the door before the big stuff happens. And there's things like this, which are just like a blog post. And you're like, oh, well, that's massive. But anyway. So yeah, so you kind of got your networking, and then you move on to your virtual machines, or EC2. So EC2 is Elastic Compute Cloud. treat them like VMs. You can get Windows, you can get Linux. You have AMIs, which are your templates, basically. So kind of the things you're used to doing on premises, where you, you can build a template, and you can build a machine, and then you can put all your standard software, security patches, CIS baselines, and then you can turn that into an AMI and then build machines from that. So there's things like, this is kind of NSX Cloud, which we'll touch on a little bit later on in AWS. They rely on putting an NSX agent into an AMI so that every machine that comes up now has that NSX component in it. It's based on the Zen hypervisor. The question here and kind of that cloud mindset is, do we care what hypervisor it's on? It's just a machine. We want to make sure it runs and it's performant, but AWS are taking care of all of that. Interestingly, they are moving to KVM, which is big news. So their new C5 instances are running on KVM, and over time they will be moving everything. All new instances will go on KVM, so they'll just run the older stuff on Zen. That news isn't news. That's being announced at reInvent, but they accidentally put it in their frequently asked questions and then pulled it out again. So little secret sauce there. They have a wide range of t-shirt sizes, so this is something to be aware of. You can't say, I want a machine with 3 vCPUs and 16 gig of memory. You need to fit into their different t-shirt sizes, but they have lots of them, from nano all the way up to 2 terabytes. So you're going to find something that fits, and they have different capabilities and different blends of CPU to memory, depending on whether you're going compute optimized or whether you're going memory optimized. And those different sort of compute optimized, those different workloads fit into different families, which, this is your acronym, isn't it?
That's my one.
It used to be TCM grid, which was really easy to remember the different families, and then they announced the P, X, and F fact, so it's TCM grid books.
Yep.
Easy. I think it's A Cloud Guru have a slightly better one, which is Dr. McGiff Picks. Yeah, anyway. It's all on their website, so you don't really need to remember too much about that. But yeah, they have different pricing models for the EC2 piece. So you can have on-demands, you pay per hour. They've just recently done per second for certain Linux AMI, so Ubuntu and the Amazon Linux. You can do, so with hourly, you just pay per hour, turn it off. You don't pay for it, although you do pay for the storage. And they have reserves, so you can pay a certain amount up front, and then you get a reduced price going forward over up to 3 years. So you can pay quite a lot, and you can reduce that. So if you have a machine that's going to run 24/7, and you're going to have it for 3 years, you can reduce the cost by 60 or 70%. But you do have to make quite a big upfront commitment. They've tweaked reservation over time that you can reuse that reservation on a different instance size, or you can carve them up. But there are some limitations, so you need to be careful about buying those. And if the machine does go away in a year's time, you can't necessarily give that reservation back. And then spot is where you bid. You say a certain price you want to pay for an instance, and if the price in their market comes down for that instance, you get that instance for a certain amount of time. That price remains at that level. They can take the instance away without any notice. So that is not where you're going to be running your domain controllers or Exchange. But it is good for running if you're doing modeling. People do this. They'll look at the pricing around the globe. If you want a batch job to run, and you don't mind when it runs, as long as it runs in the next 24 hours or next week, you can set a certain price and it will just run at the cheapest price when that price becomes available. You have different types of storage, which Alex will touch on a little bit more, but you have instant store and EBS backed. Instant store is ephemeral, so when you turn the machine off, that disappears, whereas EBS backed is your traditional kind of VMDK, and that's persistent. There isn't any overcommitment in EC2, although they do go on hyper-threaded cores. So there's some interesting blogs where people talk about where they're pushing high-performance workloads, and they're seeing issues with the hyper-threading underneath because they get a big box, they get given the whole underlying server, and they're actually trying to compete with themselves with the cores that are being given. So it's worth bearing that in mind. There's no vMotion or live migration. So going back to the previous slide about you not really caring about what the underlying hypervisor is, this is kind of important because Amazon will periodically have to do work on the underlying hypervisor. So they will email you out and say, you need to reboot your VM will be rebooted, or your EC2 instance will be rebooted at a certain time. And they can't just move that off and do work on the host and move it back again. Whilst that does sound scary, I think in our estate we've had that happen to three VMs. So they try and patch a lot of the hypervisor if they need to without having to restart services or move VMs off. And what happens with that, if you do have to do that, you reboot the machine and it comes up on a host that's already had the maintenance performed, so you can kind of schedule it in your own time if you need to, but it's worth bearing that in mind.
One of the things we were talking about as well just before we came on was this KVM announcement. A lot of the other cloud providers have a version of live migration that you don't have access to, but they can use it for maintenance. So an example would be Google Cloud. So on Google Cloud, if they're going to maintain the underlying hypervisor, they'll move your machine somewhere else. Azure do something similar, but they kind of pause your machine and then move it and then bring it back on again. So I think one of the things you see a lot with all three of the big major cloud providers is the me too. So whenever one of them comes out, like recently they were talking about per second billing, because that's really useful for everyone. So per second billing was this big thing, so then all of a sudden all of them were doing it. So again, I have a sneaking suspicion with the KVM piece that we might start to see things like live migration coming into AWS in the future.
But it comes from a history with AWS of building instances that aren't persistent. So you don't care if they're going to shut a machine down because you scale elastically across multiple instances and that machine goes down and something else comes in its place to run that workload. And you don't get any console access. So if you balk the networking on your EC2 instance, you're not going to get back into it. Like where you're used to in the VMware environment, you'd go on the VM console and you'd log in locally and fix that networking issue. That's not something you can do in AWS. To get around that, if you do manage to screw up the networking, you can mount the EBS in another machine and fiddle with it that way. Or they do provide screenshots and logs of what's going on. So if it blue screens or something like that, you'll get a screenshot of that. So you can kind of get some information. But that's worth knowing as well. Yeah, on to Alex.
Yes. So we've talked about the compute piece. So we then move into this cloud and we're talking about paradigms again. So the paradigm of moving out into the cloud, and we've got this lovely thing where machines might disappear in 2 seconds because they've just had maintenance done on them, or the underlying hypervisors are as cheap as they can possibly make them to keep your costs down. So there's no guarantee that machine might stay up necessarily for the entire month, for example. So how do we want to get around the limitations within a cloud? Well, one of the things that we want to do is we want to start to load balance and distribute our applications. And the way that we do that in Amazon is with, originally it was with ELBs, or classic load balancers. Very, very simple, very, very massively scalable, to the point where Amazon actually had they were doing a presentation one time, it's probably about 3 or 4 reInvents ago, and somebody DDoS attacked the person who was presenting. And Amazon, rather than taking the embarrassment of being DDoS attacked in the middle of it, they just scaled the entire environment up to meet the DDoS attack while it was ongoing during the presentation. They said it cost something like $10,000 for like an hour in order to outscale the DDoS attack. But that's the kind of scale that you can get with these ELBs. Then after that, they brought in something called an application load balancer, which works at a higher tier, allows you to do a little bit more intelligence around the way that you're routing traffic and things. And then most recently, they've actually given you something called a network load balancer, which it gives you something that we've been kind of looking for ages, but it almost feels like another backward step. We've moved to this brilliant cloud world, but now we still want static IPs. So as part of the network load balancer, you get things like access to doing TCP traffic load balancing and static IPs and kind of more traditional stuff. So it's kind of like Amazon are saying, let's do this amazing cloud thing, but we don't want to leave all these old enterprises around so that they, we don't want to leave them on VMware, for example. We want to bring them into the cloud, and by giving them some of the features they might expect from a more traditional load balancer solution, they then bring them more into that kind of 21st century cloud paradigm.
And in terms of the pace of new features, yesterday they announced a tool to be able to migrate from the classic load balancers into the newer load balancers, so that you can move. But I don't think the idea is not to move between them, but it's how do you get on the classic load balancers, which people have been in building environments for the last decade on. Maybe not quite a decade, but yeah, into some of this newer world without having to pull everything and then recreate it.
So, there we go. So the next thing that this then enables is once we have the ability to scale out and distribute our application, what we then want to do is actually take advantage of the elasticity that everybody keeps banging on around when we talk about cloud. Now, This is where the whole kind of unicorns and bacon, and if you listen to a lot of things like Speaking in Tech podcasts, they'll talk about these things all the time. Auto-scaling groups. It's such a simple concept, but actually to achieve it within VMware is actually really tricky, especially if you're not taking advantage of things like VRA or other more modern elements of VMware, if you've got a more classic VMware environment. Auto-scaling just simply allows you to say, right, my environment is currently running at 50%, average utilization, everything's fine. Oh, look, I've just done a Black Friday sale or whatever, and I've had 5,000 people additional hitting my website. Okay, what I'm going to do is I'm going to automatically scale up additional instances to meet that load, and at the end of that period, I'm simply going to destroy all those machines. So when Chris was referring earlier on about the ephemerality of VMs, if that's even a word, I'm going to check that one out. The ephemeral nature of VMs, then actually having something that you design that can be destroyed, created and destroyed within a matter of minutes or hours is really, really important to be able to take advantage of some of the technologies that you can use within cloud. And actually, so I work with a lot of customers on doing cloud designs, and actually this is one of the hardest things for some traditional applications, is the ability to, don't worry about the state of that virtual machine. I'm going to move the state somewhere else and then have that machine scale up and scale down, or scale out and scale in as needed based on my demand. So obviously that then gives you resilience as well. So one of the really interesting things with auto-scaling groups is they don't just scale within an availability zone. So we talked about this availability zone as being a data center. They can actually scale between availability zones. So if one of your data centers or availability zones goes down, the auto-scaling group will actually automatically restart a whole load of VMs back up to meet your traditional level of workload or whatever it is that you've actually set. So you can actually use that as a DR method as well between different availability zones within a single AWS region, which is really, really good because that's like, you think about the processes that you have to go through today in order to provide DR from data center 1 to data center 2 using SRM or something like that. Well, actually, if this can spin up the VM within like a minute of your original data center failing, what an amazing way to be able to provide disaster recovery. In addition, obviously, we talked about performance and elasticity, so actually, I'm going to move on. So we talked about storage. So block storage, or EBS, elastic block storage within AWS, is exactly the same as you would expect to see like normal block storage attached into the back of an ESXi host. So the actual VMs themselves have a similar kind of concept in the background to VMDKs that you don't really get to see, but you can do things like snapshots against them. You can run them on SSD storage or on hard disk, traditional magnetic storage, and obviously there are different costs associated with that. Now, what's really interesting is you have this concept of provisioned IOPS or PIOPS. That's just very similar to the idea of SIOC within VMware. So you can actually say this particular workload, say a database workload, I know that I need at least 5,000 IOPS on an average to be able to hit that customer demand, and therefore I'm going to set that for my particular application. And actually, maybe later on in the year, I don't need as much, so I'll turn it down. So you're only paying for however many I/O that you actually require. And then the next one is object storage. So object storage is, what's really interesting with this is we had a whole load of different object storage vendors and object storage protocols which were kind of starting to eke into the market. But in actual fact, what's tended to happen is most vendors, be it backup vendors, storage vendors, etc., they've all started to kind of converge on S3 as almost like an industry standard. Now that's really interesting because usually we try to converge on industry standards which are open. But in this case, S3 is basically owned by AWS. They could change S3 protocol tomorrow and screw over quite a large percentage of storage vendors, backup vendors, et cetera, et cetera. I don't think they'll do that because for a start off, this ecosystem has grown so massively, they're gaining and benefit from it. And if they make it easy for customers to be able to use S3, then actually, if you're then integrating that into your third-party products, then it gives a benefit to AWS because you're likely to start taking advantage of AWS's storage protocols as well. Really, really simple. You can do it over HTTPS. You can access it via browser. You can do it through API through your applications. And you also have multiple tiers. So you can say, right, I want to store all my main public-facing images for my website. I want them on S3 standard, which is like the most expensive version, but it's very high performance, very quick response time, etc. But actually, maybe I've got a load of other storage that is, I don't access it very often. Maybe I only access it once or twice a year. So I'll put that on infrequently accessed storage, and I'll pay less for that because AWS know that they don't have to provide as much I/O to that pool of storage, and therefore it's cheaper for them to run. They can put it on a lower tier of storage, that kind of thing. So there are a whole load of things that you can do to try and make cost savings within a solution, as long as you tailor that solution to the different tiers of storage that you have access to. You can also replicate S3 buckets, as they're called, between different regions. So again, from a disaster recovery standpoint, actually makes things really, really simple to make sure that your static objects exist in more than one place. And you can even version that as well. So you can have, for example, objects replicate from point A to point B, let's say from the US to the UK or whatever. And then on top of that, you can actually lock that target bucket with an MFA token and take that token and put it in a safe somewhere. So it's actually impossible for anybody to go in there and delete that data, which again, from a compliance standpoint, can be really, really useful depending on your use case. And lastly, as with a lot of AWS services, you have the ability to do encryption at rest. So it's basically a checkbox. It's really, really simple to set up. And again, from a compliance standpoint, AWS are trying to make it as easy as possible for different customers to meet their use cases. The last tier on this is called Glacia. And Glacia is something that AWS never really truly tell you anything about. I have a sneaking suspicion they're using some kind of weird, I don't know, HoloLens in the background, but they went.
Laserdisc.
Yeah, Laserdisc.
Yeah.
Somebody had to buy them. So in the background, basically, Glacia is a way to throw all of your archive data into somewhere that you don't really need to get back very quickly. You wouldn't necessarily want to put your critical backups in there so that you could hit an RTO of an hour. But what you could do is say, right, I know that I run these particular reports based on a certain amount of data, and actually I don't need that more than once a year, so I'll chuck it in Glacia. I know I'll have like a day or so before I need the data, so I'll pull it back at that point, and I'm ready to go. And again, the cost of Glacia is just insanely cheap. They did actually add some more features recently where if you're willing to pay a little bit extra, you can get that data back a bit quicker as well. Now, the next one that I find really useful is, I don't know about anybody else in the room, but installing SQL is not the thing I get out of bed in the morning to do. It's not the most exciting thing on the planet. And so taking advantage of a very, very simple PaaS service called Relational Database Services from AWS gives you access to things like Microsoft SQL, to Postgres, to MySQL. They install it, they configure it, they patch it, they manage it on your behalf, and you just have database access to it. And that's all, ultimately, for a lot of people, that's all you really care about. Yes, you do get the DBA who says, I must have access. They're usually Oracle DBAs, to be fair. But this is a really, really cost-effective way to take advantage of database as a service and integrate it within your applications. Not only that, but you can also have those databases automatically at a checkbox replicate between different availability zones. So again, from a disaster recovery perspective, we talked earlier about auto-scaling groups. You add those two things together. You've got an auto-scaling group which can automatically spin up additional VMs in another AZ. And you have your database service, which is automatically replicating to the other AZ and does an automatic failover in the event of an outage to one of your zones. So immediately, you now have an automated DR process between multiple data centers within a single region, which for a lot of customers, especially in the SMB space, that's, they haven't even got DR. Never mind having DR that's fully automated and will be back up and running within a couple of minutes. So finally, we talk about security, which is, it's usually the afterthought in most things, isn't it? Very, very briefly, you have role-based access control is really, really critical. There's a whole idea of security in the cloud versus security of the cloud that AWS talk about all the time. It's really critical that you, as an administrator of AWS, understand how the security model works and make sure that you always use things like least privilege as a key way to reduce potential attack vectors against your environment. But you have things like users, groups, all that kind of stuff. That's all fine, what you would expect. The most interesting thing is actually something called roles. So historically, let's say you needed access from a web server to a SQL server, and you'd have, say, a service account or something like that, that your web server would have to hold those credentials. Now, somebody then attacks your web server, they get hold of those credentials, all of a sudden they can then own your database. With roles, those credentials are basically generated on the fly and changed on a regular basis automatically without you ever needing to know any of them. So you basically just say, I want this VM to talk to that database server, and AWS worries about the security piece of it and constantly rotates those security credentials to ensure that even if somebody did somehow get the hold of those credentials, they wouldn't actually be able to take advantage of them. And so if we take all these together in one big solution, I'm jumping forward because we're running out of time.
Yeah.
So if we add these simple services that we've talked about, now I've used Magento, which is a really common e-commerce website solution, and I've kind of taken the solution elements that we've mentioned earlier on, I've put them into a single solution here, right? So we have, for example, an elastic load balancer sitting at the front, which is load balancing across an auto-scaling group of EC2 instances so that I can meet my peak demand during Black Friday or when I've sent out an email communication to my customers. Both of those are accessing an RDS replicated databases with MySQL going master-slave. And then I have an S3 bucket storing all of my media assets. So you can see how quickly you can actually put a solution together, a very simple solution that actually meets both disaster recovery, performance, and scalability requirements for customers. So that's kind of the intro to AWS, and we're probably way over halfway anyway, I think. So we're going to just jump into a few things that we've seen in terms of pitfalls around using AWS when you first start using it, and also maybe some stories about customers that we've seen. So first thing is, once you get your root account, basically stick it in a safe somewhere. Never ever log in as root. Make sure you create a second account immediately, and that's the one that you're always going to use. Use multi-factor authentication. It's free. You can use the Google Authenticator app, which is ironic, really, for AWS. You can set that up on your account straight away as well, so make sure that you're using that. And finally, configure billing alarms there, because basically I had an issue just recently where I started spinning some stuff up by accident due to something stupid that I was doing. And fortunately, I got a billing alarm through going, oh, did you know that you've suddenly gone up to like $15? And I was like, oh, right, okay. And I went off and turned off all the stuff that I had. So using billing alarms is a way to basically enable yourself to avoid either an accident that you've made, or actually if somebody compromises your account and starts spinning up stuff, Bitcoin mining, then you're going to get an alert. And finally, don't put your keys on GitHub. That's actually surprisingly common. This is a developer-led application platform, is a way to look at it. A lot of developers have started putting keys into their code. The code goes up on GitHub. Less than nice people go on GitHub and do searches for those keys. So now AWS themselves are doing searches for those keys to prevent their customers being ripped off.
And yeah, we said never log in as root and throw those keys away, but you might want to just keep them because there are a couple of things you need to be aware of that you still need to do with root. You need to log into root to authorize or request authorization for a vulnerability scan. So whilst you can do pen tests against EC2 instances, you need to tell Amazon before you do that. And there's a form, and you get access to that form via logging in as root. You need to log in as root if you're going to change your support plans. There's 4 different support plans. If you're going to move between them, not very common. And then if you want to close your account, I mean, you're never going to do that, are you? You're in Amazon, all your stuff's there. But if you did want to do that, then you need to log in as root and do that as well.
So a couple of kind of stories about things that Chris and I have seen just in the last year or two. One thing is, I mentioned about cleaning up after myself. It cost me a few dollars because I made a bit of a boo-boo. I had a customer who I'd met at one point a potential opportunity with a customer. And that particular customer said they couldn't understand why they had a $3,000 a month S3 bill. And it turned out what they'd done is they'd taken snapshots on a 5-minute basis of a temporary drive, and nobody noticed. And all of a sudden, they suddenly were in $3 grand a month's worth of absolutely pointless data that they were storing. So one key thing is always make sure that you're actually understanding what's within your environment. I've seen customers, for example, having war boards where every team will have their AWS spend and they compete against each other to actually try and keep that spend down. So making sure that you understand what's actually spun up is really critical. Tagging actually is a really easy way to help with that, because if you tag, very much like you can do within vCenter, if you tag every object, say for example with your project or whoever it was that spun it up, and Chris is going to come to that in a minute actually, then you have the ability to actually track where that spend is and go back to that person and say, do you still need this particular instance or whatever. And then always configure ASG health check timeouts. That was one of the reasons that I ended up making a bit of balls up. Because with the auto-scaling groups, you can actually say, when I spin up a machine, if that machine hasn't come online within a minute and a half, then something's probably gone wrong with my pipeline and I need to destroy that and recreate it as a new machine. Unfortunately, I had something where I'd set the timeout too low, so I basically didn't even give the machine time enough to boot properly. Then I went away for an hour and got myself some coffee and came back and went, oh, I've generated like 20 machines. Oh dear, that was a bit of an error. And for every one of those machines, I got charged for an hour, so that was useful.
So shadow IT inception. So we all aware of sort of shadow IT and different departments just going out and starting using the cloud themselves, whether that typically it's marketing. This was actually within our own IT department where we had an IT manager come over to me and go, look, we've got this bill for AWS. This is exactly the sprawl we're trying to avoid in AWS. This is a problem. Sort it out. I looked at this bill and the account, and I couldn't find it in any of our logins or anything we had. So I went back to him, and the login was his Amazon login. And he'd put his credit card in that he was expensing. So we were kind of, yeah, a bit of red face there. So we went through and cleared that up. And then this is a general war story. We had instances where people had sort of spun up some AWS instances, and they hadn't patched them. They'd left SSH open to the world. This is in a sandbox they were using. And lo and behold, someone connects in via SSH and starts using those machines. And that kind of typically, you see this in the media as well. Oh, S3 is unavailable, or S3 is unavailable, or someone's made their storage is open and people are pulling data out, and it's AWS's fault, or it's Azure's fault. It's the cloud. But if you did that on premises, you'd still have the same problem. You leave these things on the internet unpatched, leaving SSH open wherever they are. So people kind of go, oh, well, these things are insecure. That's not necessarily the case. It's about designing it properly, and you can make the same mistakes probably just a bit quicker in the cloud than you would on premises. So yeah, we're just moving on to talking about costs. It's the biggest upside and downside to cloud. So you can pay per second for things. You can spin things up very quickly, have a play with them. You have people competing to lower costs. You get much more visibility. This the sort of cross-charging that everyone wants to try and do within their own environment, but it's very difficult to understand power calling and your VMware licenses and all those pieces. It's all itemized within AWS, but it's the biggest downside as well, because these things left unchecked can cost you thousands of dollars, and just if someone spins up that the X2 2 terabyte instance, that's costing you a lot of money. If they just leave that running and forget to turn it off, you're going to rack up a bill very quickly. Estimating usage can be a bit difficult because of those things, whether you're scaling things up or down, and transfer rates. You get charged for egress traffic, so understanding where you're going to get charged for those pieces. And the monthly calculator is a bit rubbish. It's useful, but it's monthly, so if you want to work out how something's going to cost you for a couple of hours, you have to go there and then munge the things together. And it does have its kind of limits, but it's a good thing to go to. It's just calculator.s3.amazon. You can add things in here, all the different services, and kind of see roughly how much something might cost. Yeah, so this is, what can you do about that? That's your kind of face when you get your AWS invoice. This was a recent bug on Lightsail, which is a VPS service that AWS run. And there was a bill for $46 billion that someone got, which, yeah, it was a bit of a shock. And there were lots of reports of this all over the web, but yeah, it was just a mistake. And so they didn't actually get charged that, so yeah. So first thing is activate cost allocation tags. So if you tag all your instances, the advice Alex was giving, then you can go into the billing area within AWS and you say which of those tags you want to see on your billing reports. So you can then start to tie things back so if you tag something with a department or a cost center or an owner, go into cost allocation tags, say, I want that tag to turn up on my billing reports, and then you'll get a big CSV with all the things, and it will also have that tag, so you can start itemizing and charging them back to people. Set up billing alerts, we've already touched on. Use trusted advisors, so those 4 support levels we talked about earlier. The top 2, business and enterprise, within Trusted Advisor, which tells you about things you're doing in your AWS environment and how you could optimize them, also has cost stuff in there. So it's telling you where you could optimize costs and save some money or use reserved instances. But then the next thing is to look at third-party reporting. So because AWS is available, obviously it's on the web, you can get an API key, and you can plug it into one of these third-party tools, and they can just start pulling data in straight away. There's no firewalling on premises, what you're trying to do, all those kind of pieces. That you can just start getting visibility very quickly from one of these third-party services. They all seem to start with cloud, so Cloud Checker, Cloudability, Cloud Health. Cloud In was just bought by Microsoft and is now actually part of Azure. And they can give you other things as well, including security and compliance. So that's useful if you get to the edge of what you're seeing from a CSV and cost tags, you can use those other pieces. So design tip, I'll jump very quickly through this, but version control infrastructure. So because it's all software, there's no hardware, you can define it all in CloudFormation, which is JSON or YAML, or Terraform, which can be JSON or is Terraform's language. Terraform is great. Just go and play with Terraform. It's a really, really useful tool. Define your infrastructure. You can do Terraform plan, which tells you what it's going to change, what it's going to destroy. Also, Terraform is agnostic, cloud agnostic, or provider agnostic. So there's lots of providers providing lots of different plugins for Terraform. So you can use this against Azure, you can use this against Google. So the thing you're using for templating your environment, you can use for other clouds. You're not just locking yourself in. Well, we haven't got long, but we'll keep going.
We should have learned after 4 times.
Yeah, exactly. Which our timekeeping should be better. But so we talked about the grill in a room. So we're at our VMware conference, so we need to kind of talk about VMware Cloud on AWS. So this is Carl is back in 2013. He said, I find it really hard to believe that we cannot collectively be a company that sells books, talking about AWS, to which Werner Vogels, who was the CTO at AWS, basically said, if everyone sees us as a bookstore, we'll fine, we'll just get on with what we're doing. So that was not that long ago, it was 4 years ago. And now we've got VMware Cloud on AWS. This was obviously kind of not available when we started doing this presentation. So some of this was guesswork and reading blogs and things like that. Obviously, this is now available. VMware Cloud on AWS, there's a session, I think, at the same time as this. But that gives you a VMware infrastructure in AWS's data centers. It's running bare metal. It's licensed and supported by VMware, but you get access to AWS to plug it into. So you can start to do things where you could maybe move some of your web servers to be EC2 instances, but have your database still running in a VM in VMware Cloud on AWS. Really cool feature, Elastic DRS and resize. So how long does it take you to add a host to your infrastructure? Weeks, months. I think Frank Denneman did a poll against this. This is right-click. Within a couple of minutes, you've got a new SXI host. You can scale out. Elastic DRS, you can enable that, and that will do that for you. So kind of using the same idea of auto-scaling, it will add hosts as load increases on your environment automatically. Just jump on. So there is a ton of other AWS integrations in the past, and there's newer ones and new features now coming out. So there's NSX Cloud, so that's NSX running in AWS, putting an agent in, and you can use all the same things as you'd use on premises with NSX to use with NSX in the cloud to manage your AWS instances. And there's a ton of other things here, lots of integration and things to play with. So probably about 20 more slides, isn't it?
Yeah, anyway. There is. We like to go for slides per minute as a ratio. Yeah. So we just want to quickly run through a couple of key takeaways, and then we'll cover certification just at the very end. So key takeaways, we've already mentioned it earlier. Designing for cloud is not like designing for vSphere, but in actual fact, it's not that difficult or not that different. The key things are designing for application high availability, designing for disaster recovery, designing for performance. All of these are the same. It's just that you're doing them in slightly different ways, and you have slightly more tools in the tool bag in order to be able to take advantage of these additional services and give yourself that performance, availability, resilience, etc. Auto-scaling is just the magic bullet for everything. It is really awesome when you actually get it working properly. It can be tricky for legacy applications, but any customers or any developers who are working with modern technologies, they can typically design for and refactor their applications to be able to work within an auto-scaled environment. The key thing there is making those instances ephemeral. If they have no state, you can shoot them in the head and recreate them in no time at all and take that, gain that advantage. Use tagging for everything because it enables not only you to control your costs, but also to be able to understand exactly what's going on within your environment and whether or not those particular instances need to exist. And finally, using templates. It's the only way to manage AWS at scale is to use templates. You cannot do it any other way unless you want to never sleep. Certification. So much like the VMware tracks, there is a kind of an introduction level. So we have AWS Certified Cloud Practitioner, which is a very, very new thing just recently. AWS Associate is basically like a VCP. So they have them in several different areas. I would suggest that the Solution Architect Associate is a really good one for just kind of getting a grounding in all the AWS products, understanding the IaaS stack, etc. And then you can go on if you're a real glutton for punishment and do things like AWS Professional or some of the specialty exams. Funnily enough, when we started doing this, they had 3 specialty exams. Just goes to show the way that AWS are developing. They actually said, no, actually, we don't want to do this security one, so they just got rid of it altogether.
They were in beta, and then everyone was expecting, I think there were courses on all 3 of them, and then when they went live, they got rid of the security one. So
security is not important in the cloud, though.
No. It's fine. So I don't know if that's being re-released or something. And there is Solution Architects exams about to change. There's a new one in beta. So depending on where you are learning, you might want to take that now or wait, because it's more relevant to some of their newer services.
Disclaimer, this does not give you sufficient information to pass the exam. Just thought I'd throw that out there. So study materials, you've probably heard of these guys before. A Cloud Guru, they're based in London originally, really, really good guys. Brilliant training, very easy to consume, very exam focused as well. So there are other training providers like Linux Academy and other people who are doing training, but A Cloud Guru is, if you want to get the exam and then use that to then get your first role within an AWS role and then build on your skills, A Cloud Guru is a really, really good way of going down that route. AWS free tier, you get a whole year's worth of credit to do whatever you like within reason on AWS. And also, if you do some of their beta services, if you launch beta services, they actually give you free credit for being on the betas as well. So that's quite a useful way of topping up your account. And with the associate exams, I very strongly recommend that you do them kind of back to back within 2 or 3 weeks, because 70% of the content in each of those associate exams is actually the same. So you only then have a small amount of questions, either specifically around monitoring or about development-related stuff, that you actually have to learn to be able to pass the additional exam. So it's well worth doing that. Other learning resources, there's millions. This is going to be posted online, but you know, the one thing that I always really strongly recommend, exactly the reason you guys are all here today, meetups. It's a really good way to get information from other people. What are they doing? How are they using the platform? And then beyond that, there's podcasts and blogs.
And I would, if you want to get an idea of the cadence of what's coming out in new releases and look cool at work, because you go, oh, what about this new feature that no one else has heard of? Subscribe to that RSS feed. Or actually, we have at work, we have an if this, then that recipe, which if something turns up on that, it gets emailed to distribution lists. So other people do know about it. Maybe I should turn that off. Yeah. Anyway.
And then finally, shameless plug time. If you want to learn a bit more, I have a blog series on AWS, so you can check out my blog there. And actually, there's also, if you want to go and hear more about some awesome stuff, you can catch Chris later on
if you've not had enough of my ugly mug, I'm doing another session later on all about Virtual Design Master, which is something I took part in earlier this year. And yeah, you can find us on Twitter, which we talked about earlier that no one uses, but
yeah,
I do.
Nobody does social. And that's it. Thank you very much.